Okay, so today we're doing our topic 11 study guide. So what you're going to do is you're going to get out your graphing calculator and follow along with me. For items 1 and 2, that means numbers 1 and 2, use this data set 2, 4, 6, 9, 14. If necessary, round your answer to the nearest tenth of a unit. So number 1 says find the mean absolute deviation. This is probably the hardest thing to remember how to do. So what you're going to do first is you're going to press stat. Then you're going to press edit and you're going to enter your values. So 2, 4, 6, 9, 14. Once you're done with that, you can press second and then mode for quit so you can get back to the main screen. Now what you're going to do is you're going to go second, stat, and then scroll over to math and then scroll down to mean, press enter. We need the mean and then we need the absolute value, so you're going to go second, catalog, that's down here, absolute value. Then you need L1, everything in list 1. So you're going to go second and then 1 for L1 minus the mean of L1. So you're going to go second, stat, over to math, down to mean. You're going to type in L1 again, second, 1 for L1. You're going to close the parentheses, then you're going to move out of the absolute value bracket, and you're going to close the parentheses again, and then you're going to press enter, and you should get 3.6 is the mean absolute deviation. You might have to replay this tomorrow when you take your actual test so you remember how to do the mean absolute deviation, because it is the most complex thing probably that we've done in the graphing calculator. Okay, find the standard deviation of the sample. I made sample capital and bold because I want you to know that this is a sample. This is not a total population. So if you're looking for sample, we already have our values in there. So you go stat, calc, one of our stats. The sample standard deviation is SX. Sample standard deviation is SX, okay? So it says to round to the nearest tenth, so 4.7. Okay, number 3, what is the median of the box plot A? Okay, so the median of the box plot, this is the median, so about 12. What is the IQR? We can just do 15 minus 11 because it's Q3 minus Q1. So 15 minus 11 equals 4, so the IQR is 4. Use the two-way frequency table for items 5 to 7. How many 9th graders like rock? So we're going to go to 9th grade and we're going to go to rock, and we can see that 4 of them like rock and are 9th graders. What percent of the students in the survey are 10th graders? So you're going to go to 10th graders. The total amount of 10th graders are 40, and then the total amount of students is 50. So it's 40 over 50. And if you put that in your calculator, well, you should really know that in your head, but if you didn't, 40 divided by 50 equals 0.8, which is 80%. Complete the table for the conditional relative frequencies. Common mistake I saw with this last year is some students thought, okay, if this is 40 and this is 68 and this is going to be 28. That's not how it works. It works that way when you have like numbers like this, but when you have percentages, it does not work that way. What we need to do for conditional relative frequencies is we need to take this value, we need to refer back to this table, and then put it over the total value in this column over here. So it's really 30 over 40. So this column is 30 over 40, and 30 divided by 40 is 75%. Okay, so this column is 30 divided by 40. You need to refer back to this table. So then for this one, it's going to be 10 divided by 40. So for this one, it's 10 divided by 40, and 10 divided by 40 is 25%. Okay. Next, number 8, which of the following best describes the box plot? Select all that apply. Okay, number A says the data set is skewed to the right. It's not skewed to the right because we can see that there's a long whisker on the left, so it's actually skewed left. The data set is skewed to the left, so that's an answer. About 50% of the values are between 10 and 17. That's correct. So 10 and 17 is here. And remember, Q1 to Q3, this is always 50%, so that's right. You're also going to need to know that tomorrow, on your quiz, the question's slightly different. From here to here is 25%. This is always 50%. And this is always 25%. So tomorrow it's going to be slightly different. Keep that in mind. And then D, about 50% of the values are between 2 and 10. No, that's 25% of the values. So B and C are the answers. Next, in the data set, the mean is less than the median. What does this indicate about the data? If the mean is less than the median, that means it's skewed left. Number 10, data set A is a normal distribution. This is important. If it's normal, it's symmetric. And if it's symmetric, that means the mean and the median are about the same. With mean 10 and mean absolute deviation 2. Data set B is a normal distribution, again, with mean 10 and a mean absolute deviation of 5. Which best describes the data set? Select all that apply. They both have the same shape. We can't necessarily say that they most have the same shape because they might both be symmetric, but one of them might be more like this, and the other one might be more like this. So it's not like they necessarily have the same exact shape. They both have the same median. That is true, and the reason why that's true is if they're a normal distribution, that means that the median is going to be 10 for both, because the mean and the median are about the same when the distribution is normal or symmetric. So this is correct, B. They are both symmetric about the mean. That is true because they're normal. Data set A is more spread out than data set B. No, it would actually be the opposite. Okay, next. This question, I whited out because, I don't know, it gave you like choices and then the choices, none of the choices were right. I think something happened with the formatting on my computer when I converted this and it like shifted all the box plots. So I'm just gonna make you draw a box plot for this. So instead of which box plot, just draw a box plot. Okay. On your test though, I think I made it multiple choice and I think it's right. Okay, which box plot represents the data set? Okay, so what you're gonna do is you're gonna go to Stat in your calculator. You're going to go to Edit. You're gonna type in these values, so up, clear, down. So 1, 1, 4, 4, 4, 9, 10, 10, 10, 14, 14. Then you're going to press Stat, over to Calc, one of our stats. This gives you everything you need to know. So we know that our min is 1, so I'm going to put a minimum at 1. I'm doing this in pen because it's really hard to write on whiteout. Okay, there's a minimum at 1. There's a max at 14. Q1 is at 4. Q2, or the median, is at 9. And then Q3 is at 10. So then you draw the box, and you draw the whiskers, and you're good. Okay. Use the histogram for items 12 to 14. How many values are in the data set? So we have 2 here, we have 2 here, we have 3 here, and we have 5 here. So 4 plus 3 is 7, plus 5 is 12. What percent of the values are between 10 and 30? Round to the nearest tenth of a percent. So 10 and 30, that's from here to here. So that would be 4 values. 2 plus 2 is 4 out of a total of 12 values. So 4 divided by 12 is a third, so that's 33.3%. The median value of the data set is 39. What could the mean of the data set be? So if this is skewed left, because this is where the tail is, right? This is skewed left. If it's skewed left, that means the mean is less than the median. So if the median is 39, the mean has to be less than that. The only value here that's less than that is this one, 32.5. What is the mean of the data in the dot plot? You can do this longhand, add them all up, divide by how many there are, or you could just put your values in your graphing calculator. So 10, 10, 20, 20, 20, 30, 40, 50, 80, 90. Stat, over to calc, 1 bar stats. The mean is x bar, and x bar is 37. Okay, next. What is the standard deviation of the data? Use population standard deviation. So now I want you to use population. So we're pretending that these are all the values that were collected. So population, you're going to go to sigma x. So instead of sx, you use sigma x. So that's 26.85. You could round it to 26.9. It doesn't really matter. Or 26.85. I didn't tell you what to round to, so it doesn't matter. Will the median value be to the right or left of the mean? Okay, this is worded kind of weird. It's worded kind of backwards. Will the median value be to the right or left of the mean? Well, if we look at this dot plot, it's skewed right. Okay, so the tail is here, so that means that it's skewed right. If it's skewed right, that means that the mean is greater than the median. So if the mean is greater than the median, that's going to mean that the median is going to be on the left side, okay? So this is just worded a little bit weird, so you have to be careful. A survey of birds in forests A and B counted the number of robins and sparrows, used the resulting frequency table for items 18 to 20. What percent of the robins are in forest A? Okay, so what percent of the robins are in forest A? So robins in forest A is 9, okay? And what percent of the robins? There's 45 robins altogether. So you're gonna do 9 over 45, and when you do 9 divided by 45 in your calculator, that's 1/5. You could do that in your head too, which is 20%. Next, what percent of the birds in forest A are robins? So the birds in forest A are 25, and then the robins are 9. So it's going to be 9 over 25. And 9 divided by 25 is 0.36, so that's 36%. What percent of the birds are robins? Okay, so there's 45 robins altogether, and there's 125 birds altogether. So you have to do 45 divided by 125. So 45 divided by 125 is 36% again. All right, last questions. During 1 month, the mean high temperature in Boise, Idaho was 52.1 degrees Fahrenheit with a standard deviation of 6.5 degrees Fahrenheit. During the same month, the mean high temperature in Death Valley, California was 81.9 degrees Fahrenheit with a standard deviation of 6.4 degrees Fahrenheit. Which of the following are true? Select all that apply. Okay, this you might have to refer back to your notes. When we learned about standard deviation, we did the book section on that. We learned about how it's like 68% of the data is 1 standard deviation away from the mean, and then 95% of the data is 2 standard deviations away from the mean. So this says about 95% of the high temperatures measured in Boise ranged from 45.6 to 58.6. So that's 2 standard deviations away from the mean. So let's check. So we're talking about Boise, Idaho, so we have to look at this one. The standard deviation is 6.5. So if we take 52.1 and we add 6.5 and then add 6.5, we get 65.1 on the high end. So this is not right. The average high temperature in Death Valley was greater than the average in Boise. So the average temperature in Boise was 52.1 and the average in California was 81.9, so that's correct. The variation of high temperatures in Death Valley was about the same as the variation in Boise. Variation is talking about standard deviation. 6.4 and 6.5, those are super similar, so yes. Now, tomorrow I'm going to change some of these questions a little bit. But if I'm changing them, I'm making them easier, not harder. So, like for this question, I'm changing it. I'm adding a couple of easier ones to help you out a little bit. So there will be some on here tomorrow that are a little bit different, but if they are different, they're going to be easier, not harder. Okay, that is it. Study up.